Hello and welcome to the Hubble Cast, the podcast that helps you go beyond Earth. I'm Sama Bukhamseen and I'll be your host for this podcast. For today's episode, I'll be discussing a very exciting and anticipated topic, and one of the greatest mysteries of science, which is dark matter. I imagine some of you have heard of dark matter in the past, but some of you haven't. So I'm going to give a brief explanation of what it is and how it's being discovered. To begin with, as time passed since the creation of the universe, first stars began to form. Galaxies formed as stars gathered, and galaxies started to group together. The galaxies and all the matter in between the galaxies make up those clusters. The planets in our solar system started to form around the sun as clumps of matter collided with one another. And our solar system, galaxies, and galaxy clusters must all be connected by some force. When you think about it, there's got to be some type of force that's holding all of this together. And that glue is gravity. Now, some clusters include gas in the gaps between galaxies that is so hot that it is invincible to observatories that use visible light. Only X-rays or gamma rays may be used to observe the gas. The amount of gas between galaxies and clusters is measured by scientists when they examine that gas. As a result, they came to the conclusion that there must be 5 times as much materials in the clusters as what we can see. Dark matter refers to the undetectable and unseen matter. So when you really think about dark matter, it's essentially what we don't know rather than what we do know, which is what makes it so interesting and appealing to many people. Now, in the 1930s, Swiss astronomer Fritz Zwicky coined the phrase dark matter, and he focused on the rotational speed of the so-called Coma galaxy cluster. And similar to merry-go-rounds, clusters like the weight of the items and their placements on a merry-go-round. The rate of revolution is dependent on the weight and the location of the objects in the clusters. The cluster must have had a lot more mass than the observed light suggested, according to the speed that he measured. And by examining galaxy rotation in the 1970s, American astronomer Vera Rubin and her colleagues were able to validate this finding. Additionally, they have found that individual galaxies as well as clusters contain more mass than what their apparent light suggested, which is really interesting when you think about it, and it makes you think about how much we actually don't know. Now, the research of Rubin and her colleagues contributed to the solidification of the idea of dark matter, since it wasn't really confirmed or solidified in the community. Though they have some theories about what dark matter may be, in many respects, scientists know more about what it is not. As I mentioned before, we technically know what dark matter is not rather than what it is. Now, considering what it may be, brown dwarfs, stars that fail to ignite because they lack the mass to begin burning, may make up some of the dark matter. As well as that, white dwarfs, which are the remains of the cores of defunct small to medium-sized stars, may constitute dark matter. Alternatively, dark matter may be neutron stars or even black holes, and the byproducts of massive stars exploding. However, each of these recommendations have its drawbacks. Strong evidence suggests that there aren't enough brown or white dwarfs to fully explain dark matter, which again makes you question about what it could be. Both black holes and neutron stars are uncommon as well, which shows its drawbacks. Now, it's possible that dark matter is entirely constituted of substances that aren't recognizable to us, and different materials might make up dark matter. It may be full of particles that theory anticipated, but that researchers haven't yet seen. And since dark matter cannot be observed directly, scientists have discovered alternative methods to study it. We can learn things indirectly. For example, by observing a shadow and speculating about what caused it. Utilizing gravitational lensing is one indirect method through which scientists investigate dark matter. light passing through an optical lens is comparable to light passing through a gravitational lens. It deforms, basically, and it bends. The gravity of the mass contained in the galaxy or cluster causes light from far-off stars to bend as it travels through it. As a result, rather than originating from its true source, the light appears to be coming from somewhere else. The degree of bending teaches researchers about the dark matter that is present. The Hubble Space Telescope is used by several NASA researchers to study gravitational lensing, and this has been one of the main methods that researchers and astronomers and astrophysicists have used in order to understand dark matter and what it may be. In addition to these indirect methods, NASA researchers believe that they have a direct method utilizing the Fermi Gamma Ray Space Telescope to find dark matter. The highest energy type of light, gamma rays, are the subject of this telescope, as indicated by its name. It's possible for two dark matter particles to collide and emit a gamma ray. These collisions, which would manifest in the sky as a burst of gamma rays, may conceivably be picked up by the Fermi telescope. Since Fermi has just recently been in the orbit, scientists do not yet have enough information to draw conclusions. Although it is quite disappointing to see that scientists still don't have enough methods and technology to really understand what dark matter is, seeing as all of the new technology and especially the artificial intelligence that is being developed in our world today, I can definitely see a lot of advancements happening in this field, and I can definitely see a lot of people who work in the space industry using these new developments in order to create new gadgets and telescopes in order to be able to find out what dark matter is, since it is such a mystery. Although it's very interesting to see the indirect methods that many NASA researchers have been using and utilizing in order to understand dark matter. And a great example of this is the gravitational lensing, as it is technically an indirect method that they're using to find out what dark matter is. It's not a direct indication, but since light passing through an optical lens is comparable to light passing through a gravitational lens, they're able to use this method to understand more about dark matter and what it is. But then again, dark matter could be anything. And as I said, it could be a particle that is theoretically a thing, but in real life, it hasn't been anything that we've seen before or even discovered. So that is it for today's episode. I really hope you guys enjoyed listening to this episode as we discuss an extremely interesting phenomena in space science. And it's definitely a phenomena that's more new and not as repeated, and something that a lot of people don't really know about. So I really enjoyed discussing it and talking about it and teaching you guys about such an interesting phenomena. Now, always feel free to ask any questions in the comments. I'll definitely be answering as many of those as I can. And feel free to recommend future topics that you'd like to see discussed on this podcast, as I also like to look at those recommendations and take that into consideration when creating the podcast. Make sure to stay tuned for any future episodes, and goodbye.